Welcome back to the channel. Today, we have a FunBox. This is marketed as a 3D printer for kids, and honestly, in the latest years, the advancements in technology made it super easy for anybody to use a 3D printer, especially kids. You don't really need to be a software or electrical engineer anymore to figure them out. So most of the models on the market are already easy enough for kids to get a hold of. And this is a great way for kids to start dabbling with 3D modeling, printing some stuff of their own, and actually even maybe starting a small business. I keep seeing more and more regular people, not really tech enthusiasts, going into 3D printing just to make trinkets for around the house, functional parts, or just again starting a small business selling at fairs and whatnot. So let's see what makes this a 3D printer for kids, what advantages it has, and how it stacks up. First, we need to do the unboxing. And right on top, we're greeted with a bunch of nice, funny stickers and what looks like a user manual. Then, the top piece contains a very little, cute, small build plate, which is magnetic on the back, the filament holder reel. We have here some test filament included. We have side cutters, very useful to cut the ends of your filament, and then a hydraulic push connector, looks like a 4mm one. And then we have the 3D printer itself. That's basically everything that was in the box. So let's remove this from the plastic. And straight off the bat, you can see how small and cute this is. I must say it's also relatively light. It's not very heavy compared to other printers I reviewed recently. On top, we have an information label that is for kids between 4 and 12 years old. And then we have some QR codes here with an unboxing guide and a manual. First thing first, we remove this piece of tape. We then remove this foil on the front door. We have some more plastic here to peel off. And inside the printer, we have some more foam holding in place the hot end and also the power adapter. We're gonna use the included side cutters to cut the zip ties holding on the power adapter. And it looks like this printer only needs 60 watts. There is also a zip tie holding on the hot end in place. So we're gonna take care of that really quick. And if we take a look inside the printer, we see that it actually comes with a filter to filter out some of the gases and particles you might get from melting plastic, of course. This also is removable, and behind it I can see a fan that's blowing air out right here. So let's put the filter back on. A filter is always a nice addition to make printing safer for everybody, so I appreciate them including that. I can also see in the top right corner here there's a webcam or a camera of some sorts, and altogether it looks like a pretty simple machine. If we turn it around to the back, we see that it's a Bowden style extruder that sits right here. We have a power switch right here, the input for the power, and then a USB cable connection. So first impressions, this really looks like something that would go well in a kid's room and wouldn't really stand out, be out of place, or even take up that much room. It's pretty compact, pretty nice. Installing the build plate should be pretty easy. We just put it in its spot. Now we can go ahead and install the filament holder reel on the back, which you just twist in place. And it has a positive click to let you know when it's actually seated. Let's install the provided filament to run the initial tests, of course. And this is another place where the included side cutters are going to come in handy, because the end of this filament reel is not super tidy, so we're just going to snip that. Install it right here, and then fit it into the extruder, which is super easy. We can then press the lever. We can then press this lever here to disengage the extruder and actually push the filament through all the way to the hot end, and we're done. Next thing, of course, is to plug it in. So let's do that right now. One thing I want to say here is the power cord is not that long, maybe a meter, 1.20 meters. So this will need to be pretty close to a power outlet. So after powering on the printer, I went ahead and installed the UGEE app on my phone. There's also going to be a slicer version for Windows. Let's overlay the phone right here. And as you can see, we have the printer on the top left that's connected to Wi-Fi and my phone. On the top right, we have a settings button where we can rename the printer, update the firmware, we can see the IP address, find your printer, which is going to make it beep. Then we have some options to change filament, which, because we just manually inserted the filament, we can actually go ahead and click load filament. So now it's going to home the hot end, and then it's going to start heating it up to load the filament. And it already started. Because this only draws 60 watts from the wall, it's not going to be the fastest heating time ever. So I'm just going to cut and be right back after this is loaded. After the nozzle is fully heated up, we also get a progress that shows us how far along the loading process is. Right now we're sitting around 20%. And we also get a prompt on top saying, check that filament is flowing from the nozzle. When it does, tap finish. So let's check. And it looks like our blue filament that we loaded is actually flowing. So we're gonna hit finish. Now we can go back, clean the printer. So remove the oozed filament. And after removing the oozed filament, we can also check the calibration. And it doesn't allow us to do that because the nozzle is still hot. Okay. There's also options here for leveling, which also doesn't work for the moment. We can actually manually move the print head. Right now it's at 0 on x-axis and we tap 10 millimeters. And we can actually move it manually. Then the y-axis, again, 10 millimeters, and the bed is moving. And then the z-axis, we can also tap to go down by 10 millimeters and so on. There's also an option here for preheating, and here we can actually click start cooling because we want to cool down the nozzle so we can do the initial calibration. What I really appreciate here in the software, and something that's really useful for kids, you get a lot of prompts when something could be dangerous. Like for example, here on the bottom it says, do not touch the nozzle while it is cooling, trying to actively prevent somebody from getting burned if they never use the 3D printer and they never really know that the nozzle and the hot end assembly are actually pretty hot when printing or after loading filament. You don't want to go and touch the nozzle and get a burn, so we always get these nice prompts telling you not to touch the hot parts, which is good. While the nozzle is cooling, we can still go through the settings and we can turn on and off internal lights. We can also turn off the status lights, which are here in the front. We can turn on the cooling fan on the left side here. We also have options for power loss recovery, printer alerts, filament detection, and tangle detection, which is pretty good. And all the way at the bottom, we have a button to restore factory settings. And now that the nozzle is cooled down, we can go ahead and do the bed calibration. We use this card right here that was provided in the package. We place it in the middle and then go hit calibrate. Now the nozzle should do the automatic mesh bed leveling, and if the nozzle is too far on some points of the bed, we can just use the phone and adjust the offset accordingly. And we should adjust this until we feel slight resistance on the card, so we can go maybe 0.1 lower. And now we have the required resistance, so we're gonna hit save. And now, once the calibration is done, we can go ahead and actually try to print something. We go to Explore Toys. And then we can just choose something from here. Now, ideally, I would like to print a Benchy as the first test. That's a good comparison to other printers. But because this is more tailored to kids, the software here and the whole environment has some other models where I cannot find the Benchy. So because our filament is blue, I'm gonna go ahead and print this Twitter bird. I'm not even gonna touch the settings, I'm just gonna hit print now and see how the printer deals with it. So we have some checklist before starting to print. We need to make sure the filament is fully loaded, which we did earlier. The base plate is installed, so we're gonna hit do not show again. Got it. It tells us it's gonna take 20 minutes and 6 grams of filament, so we're just gonna hit print. Right now the app is uploading the model and the G-code to the 3D printer, and it seems like it already started. Let's close the door, because that's always good practice. And we can actually remotely follow it on the camera right here. So we already have the name of the file, time remaining to print, progress it's saying warming up. So I'm just gonna let it run, and we're gonna be back after it's done. And now with the print done, let's see what came out. Removing the build plate is super easy, and we can see here a purge line on the bottom, pretty standard. It looks like the model was printed on a raft, so let's see what the adhesion is. It actually adhered pretty well, and after we remove the raft, we're left with the cute Twitter bird. The quality seems okay. It's not the best I've ever seen, but I'm not really expecting that from a kid's 3D printer. Top surface is nice and smooth. There aren't any noticeable airlines. Of course, the bottom is not going to be that impressive, being that it was printed on a raft, but that's okay. So let's go ahead and print some more. First, we need to clean up the build plate, of course, and that involves just peeling off the existing raft, which I must say adhered pretty well to the build plate, and of course the purge line as well. And with all that cleaned up, we can reinstall the build plate. Close the door and see what other models we can print. Going back to the app, we can also see a prompt here with print complete, and again saying be careful of high temperatures when removing the print, so really like to see that. Going back to models, we can check out some more. Let's see what's over in the education side. We have here a bunch of logos, some ball fidget spinners, some flowers. So something that could be fun for kids are fidget spinners. So let's go with this clicky fidget. It's a print in place rotating fidget toy. So let's go ahead and print that one. And again, uploading successful, and the printer is homing. Looks like this print is gonna take 38 minutes, so we're gonna be back after that. Okay, so in the meantime, I printed some more things. Let me go ahead and show them to you. First, there was this super satisfying fidget toy, which was printed in place, and it actually came out really nice. This is one of the models that did not print on a raft. And as you can see, everything spins freely and nicely, and it has this spring here that actually creates the clicking sound regardless of the direction you twist this in. So a successful print. I then went ahead and printed this sort of crossbow or spring bow, which is very good to teach kids about elastic momentum and stored energy, because the moment you press this trigger, it actually shoots a Q-tip out of the front of it. And then the springs come back in their resting position. Again, this was printed on a raft, so the quality here on the bottom is not the best, but the part was still fully functional using the provided PLA. Next up, I decided to do more of a torture test, and I printed this pumpkin that actually spins when you turn it upside down. And why am I saying this was a torture test? Because as you can see, it has a lot of start and stop print sections. This is more like a Voronoi or hole pattern. So this was pretty tricky for any printer to print, and the UGEE FunBox actually did pretty well. All the other details came out nice. There is nothing really wrong here. And again, print in place, it worked perfectly. This was printed with a raft, but again, no problem in functionality. And finally, let me show you the last one, which is still in the printer. And it actually is a model of the MIT University. For this, I actually used some PLA that was provided by UGEE, that is actually color transitioning. So as you can see, it starts off as orange and then it goes into a pink sort of purple. Let's remove this from the raft, which is super easy and fast. The first layer after the raft actually looks quite decent. It's not that bad actually. There is a bit of warping that I can see here. If we look down the model, there is a bit of warping in the corners. And even though this was PLA, it still happened. And another small little defect I can see are a bit of wisps here. Some stringing happened. Also, because I set the printer on the fast print mode when I started this, I actually enlarged this to make it as big as the build plate could handle, so I can print the biggest version I can. And using the fast mode to actually decrease the print time caused the extruder sometimes to skip, because it was trying to print too fast compared to how fast the hot end would actually melt the plastic. Regardless, the model came out okay. There aren't really any visual defects I can see because of the under extrusion, but I could hear it skipping while doing the infill and some other rapid movements. So time for some conclusions then. If you have a kid that's interested in getting into 3D printing and wants a printer that is extremely easy to set up, requires almost no adult interventions, maybe just a bit of supervision, as the label says, the UGEE FunBox is a good option for that, and I have no problems recommending it to, again, any kid between 4 and 12 years of age.
But UGEE will launch soon their window slicing platform called UPrint, which will make it much more easy for kids to create and print their own 3D models.
But regardless, it's a good printer for kids to understand the process, start getting into 3D printing, and maybe later when the slicer is released, even start doing some 3D models of their own. If you enjoyed this video, consider giving it a thumbs up, subscribe to the channel for more tech videos like this one, and I'll see you next time.